Once we become comfortable with the Pythagorean theorem, we can start discussing some of the other results of the Pythagorean theorem. Specifically, what if I don't know what kind of triangle is being created with my sides? Example 1, if I give you 3 sides to a triangle, I say 5, 8, and 11. In a previous video I showed you to first show whether or not a triangle could even exist. To do that, we would test the existence. So I'm questioning that. Could this even make a triangle? How to do that? I will subtract the 5 from the 8. I'm looking at the 2 legs, the 2 supposed legs. So 8 minus 5 would be 3. And then I would add those 2 sides. 8 plus 5 is 13. And really what I'm looking at this not as an ordered pair. This is something called interval notation, but this as a shading, a series of values that could possibly be the third side. Does 11 fall between 3 and 13? Of course it does. So yes, we have a triangle. The existence of a triangle sure could be a triangle. So we say we have a triangle. So a triangle exists. Now, phase 2 to this process, once you know that you could have a triangle, now you want to try to classify it using the Pythagorean theorem. Now the Pythagorean theorem, we know that we can take the leg squared plus the leg squared, and we're going to question how is that related to the hypotenuse once it's been squared. And so I'm going to take these values of 5, 8, and 11, I'm going to put them into this so-called formula and see what the result is. So I'll take my 2 smallest values, which would have to be my legs, and say 5 squared plus 8 squared, and question that, how is that related to 11 squared? So if we square 5, we get 25. And if we square 8, we get 64. And we're questioning, how would that be related to 121? So of course, if we add that up, we get 89. 89 is smaller than 121. Now, as a picture, we're looking at this, and you've got to realize you've got this hypotenuse, it's 11, and these 2 legs. What this is saying is that the legs are short. The legs are small. So if you could imagine having this distance that you're trying to spread, if you had a shorter person, their legs would be really stretched out. And you would ask yourself, well, what kind of triangle would that create? And as you look at this angle in here would have to be obtuse. So if you have short legs spanning a hypotenuse, that would create an obtuse triangle. So in other words, the results of this, when we look at the results of the Pythagorean theorem, if you have a leg squared plus a leg squared being smaller than the hypotenuse squared, that would imply that you have an obtuse triangle. If you have a leg squared and a leg squared and it equals the hypotenuse, well, this is what we've been learning. That would be old hat, so we'd say, oh, that's got to be a right triangle because it's equal. It means it perfectly fits in there. And then you can probably guess, if you have leg squared plus leg squared being greater than the hypotenuse squared, that would mean that you have an acute triangle. Again, a picture for this one, for this third one. If this is your hypotenuse, and say you had a really tall person, they may not need to spread their legs very much to span that distance. So as they stand like this is a long-legged person, this angle that we have right here would be very small. And so we'd say, oh, that's an acute triangle. And so when we look at this, your gut may be telling you, that seems a little bit backwards. Leg squared plus leg squared is less than the hypotenuse squared. You're telling me it's obtuse. Yes, because you have to span a huge distance with short legs. When they're equal, it's a right triangle. And when you have those long legs and you're trying to span a smaller distance, you don't have to spread your legs out quite as far. So you would just say that that's an acute triangle. So when the legs are less than, you say obtuse. Legs equal the hypotenuse squared, it's right. Legs are greater than the hypotenuse, then that would imply that you have an acute triangle. Now as we go back to my first example here, I had this 5, 8, 11. 5, 8, 11. I decided that I could create a triangle with those three sides. As I did the subtraction and the addition of the two legs, found that the third side fell between 3 and 13, so the triangle existed. As I applied the Pythagorean theorem, I found that my legs were less than the hypotenuse. With the legs being less than the hypotenuse, it told me that I had an obtuse triangle. So I could classify this as an obtuse triangle. Simple as that. And that's our first example of the other results using the Pythagorean theorem.